Hello, good morning, everyone. Uh, Thank you for joining in this webinar today. In today's webinar, we have Mr. Naveen CJ. He's from Bosch, Bosch Global Software Technologies, and he's an expert in Industry 4.0 and associated tech. And that is the topic he is going to brief us upon. He also plays the role of Senior Program Manager as part of the Product Engineering and Strategy Group. So over to you, Naveen. Thank you for joining us today. And just give us a brief about yourself and the topic, and you can start.
Thanks, Chinmay, for the short introduction. I'll share my desk. Perfect. Yeah. As Chinmay mentioned, I'm very fortunate to work on some of the most exciting projects that drive Industry 4.0 transformation. I'm with 20 plus of years experience, with particularly focus on industrial robotics, drives and controls. Today, I'm excited to share my experience and insight about Industry 4.0 and smart factories with you, especially as you, the next generation of engineers, prepare to embark on your career in an industry that is rapidly evolving. Just take you the agenda for this session, a brief introduction to Industry 4.0 and smart factories, more about providing a high-level understanding of industry as a whole, and overview of core technologies enabling smart factories means that drive smart interconnected manufacturing environments. And the third is the manufacturing automation pyramid. Yeah, here we learn how the pyramid structure connects machine controls to enterprise planning, enabling smart factories, followed with skills and tools for future smart factories, because it's very essential skills and tools that are key to succeed in industry 4.0 for any engineering student. At last, we learn how to prepare for an exciting career in the smart manufacturing industry. This is the overall agenda I covered here. Yeah, let's start how the industry works. Yeah, and what is industry 4.0, factory and smart factory at a nutshell. Imagine a world where things are you use every day, like your smartphone, laptop, home appliances, or even the car you drive, are created through a complex but fascinating journey. The journey begins with raw materials like metals, minerals, and ends with finished product. This is where industry come into play, as it is a force behind transforming these raw resources into something useful and essential for people. Industries are not just about making a product, they are about creating a jobs, boosting economies, and sparking new technologies that reshape our life. Just to overthrow what all the different types of industry, over the time we have come to see four main types of industry, each with its unique role in the journey. You know, just a minute, I'll just switch on the laser beam. Yeah, the first industry category is primary industry. Think of it as an beginning of an journey. This industry extract resources from nature itself, whether it's a growing crops, mining metal, or fishing in the ocean. It's about harnessing natural resources to get what we need. Example like agriculture, mining, and forestry. Second industry is a secondary industry. This is where things get really interesting and where we all focus our discussion today. This is the secondary industry. Here, raw materials from primary sector are transformed into finished goods. Factory, assembly lines, and entire manufacturing processor turns research into product we use every day. Think about factories like manufacturing, construction, and food processing and textile product. This is the area which is marked in green color we're going to focus today. Just to touch upon, the third one is a tertiary industry, also known as service industry. It's more on connects consumers and business with the services. The fourth is the quaternary industry. This industry drives a knowledge economy by focusing on innovation and expertise, like IT services, R&D, data analytics, and financial planning. As we dive in our discussion today, more on the center part, this is where Industry 4.0 and concepts of smart factory coming to the picture, taking traditional manufacturing and transforming it with advanced technology. This picture illustrates how manufacturing industry takes raw material from primary industry and transforms them into finished product through various manufacturing processes. As mentioned in the session, we will focus in the middle layer, middle section of this process where digital transformation is revolutionizing manufacturing industries, optimizing efficiency, and enabling smarter product methods. Okay, let's understand Industry 4.0 a bit before getting into the new technology, what it supports. Imagine you stepping into time machine that takes you on to incredible journey through the revolutions that shaped our modern world. It all started with Industry 1.0 in the late 18th century. Let's think a time where most work was done by hand until the arrival of machines powered by water and steam. The first industrial leap replaced muscle power with machine power, fundamentally transforming production and igniting the industrial age. Fast forward to the 19th century, the Industry 2.0, the age of electricity, the Industrial Revolution brought about assembly lines and mass production, allowing goods to manufactured at an unprecedented scale. Factories coined here with productivity, driven by new complex machinery that took manufacturing into next level. Next, the Industry 3.0 in the mid of 20th century as computers and electronics sparked a new wave of automation machines and early robotics made production more precise and efficient. With cost dropping and productivity surging, factories were evolving into technology hubs, waving in electronics that would shape our future. Today, we are in the era of Industry 4.0. We have smart factories where IoT, Internet of Things, artificial intelligence, data analytics converge at this point. Imagine a production line that you think for themselves, machine predicts their own maintenance need and interconnected system working in harmony. Real-time monitoring, advanced data insight, and adaptable manufacturing have transformed production from rigid processes into flexible, intelligent system. You know, each revolution, each revolution has propelled us closer to today's digital marvels. Each one driven by desire to make production more efficient, cost effective, and safe. As an engineering student, you are not just studying this journey, you are poised to shape the next transformation because Industry 4.0 is where power of idea and technology collide and converges. And you are part of new generation that will continue to redefine what is possible in future. Let's have a short look on smart factory. Smart factories are integral part of Industry 4.0 transformation. Smart factories represents next generation of digital manufacturing, integrated advanced technologies to create highly automated data driven production environment. Through automation, smart factories reduce downtime, increase throughput, and enhance overall efficiency. Smart factories are also highly adaptable, enabling them to respond quickly to the change in demand and easily scale production up or down. Imagine, just to understand, imagine you walk into factory, but this is not any ordinary factory. The machines seems talk each other, the production line adjusts itself automatically, and engineers monitor the entire operation from their smartphones. This is the old of Industry 4.0, a smart factory, a new era of manufacturing where line between physical and digital world are removed. everything from machine to worker is interconnected, smarter, and more efficient. So, let's explore what makes a factory smart and how Industry 4.0 is changing the way we build, we create, and we innovate. Okay, before exploring new technology that drives smart factory, let's understand manufacturing industry bit in a structured way. Imagine you walk into a high-tech manufacturing facility where every process from the smallest machine operation to the strategic business decision flows seamlessly. Behind this journey, behind this harmony is a powerful structure defined by manufacturing segment known as manufacturing automation pyramid, a system that organizes, controls the layer of technology in manufacturing, particularly in Industry 4.0 and smart manufacturing environment. Think of this pyramid as a bridge connecting business strategy at the top to the hand on work on the shop floor. This structure helps to ensure that decision made at the top level flow to the bottom level efficiently to the machinery, enabling data driven manufacturing with streamlined communication across layer. To make this layer interoperable, the International Society of Automation introduced a standard of organizing the structure into 5 levels, 0 to 4, each with its own essential functions. Level 0, the foundation of pyramid where actual production happens. This is the typical physical layer. The machinery and equipment performs tasks. Then comes the level 1, basic automation systems monitor and controls the equipment. Here devices like PLC, programmable logic controller, motion controller handle simple tasks and basic machine operations. In the second level, at this level, systems like SCADA, supervisory control, data acquisition, and HMI, human machine interface, supervise and monitor the production processes, allowing operator to oversee and adjust the process as and when needed. Level 3, this is a manufacturing execution system layer where production becomes a coordinated MES system manages real-time production activities, tracking work in progresses, ensuring quality, scheduling operation, and capturing valuable data. At the top, finally, level 4, Enterprise Resource Planning ERP. This layer deals with high level planning and business operations such as sales, procurement, inventory management, and production planning, aligning production with overall business objectives. As an emerging engineering student, understanding this structure means mastering the art of coordination between technology and business. This is a very critical skill in Industry 4.0, where systems must operate seamlessly from factory floor to the execution strategy. The manufacturing automation pyramid is not just a concept, it's a roadmap to build future smart factories. Okay, so how does this all work? Industry 4.0 is powered by several key technologies. Let's have a short look on that. Advanced robotics. Robots are taking over the repetitive and dangerous tasks on the shop floor, working alongside humans. These robots are smarter than ever, equipped with sensors and artificial intelligence. They can adapt to changes and handle complex tasks that were once impossible for earlier machines. Next, have a look on Internet of Things. In Industry 4.0, Every device from smallest sensor to the largest machine is connected. This is Internet of Things, an intelligent network of devices that communicates with each other. Think of machine that can talk to the maintenance system and alerts engineer before it breaks down. IoT makes factories smarter and more efficient by collecting and sharing data. Once data are available, the cloud computing lets all the data collected from the machines be stored, analyzed, and accessed from anywhere. It is like having a central brain that controls and optimizes this entire factory, ensuring everything runs smooth. Big data analytics. The factories are generating massive amount of data once becomes IoT enabled industry. But it is not enough just to collect data. Industry 4.0 uses advanced analytics to turn that data into actionable, meaningful insight, whether it's a improving product quality or predicting a breakdown before it happens. With this massive data and big data analytics, artificial intelligence, machine learning, cognitive computing, it's all plays a bigger role. Now imagine a factory where machine don't just follow instruction, they learn from experience. That that is what artificial intelligence and machine learning do. They analyze data, predict outcomes, and improve operations over time. For example, AI can optimize the speed of assembly line based on past experience, adjusting is real time to get the most out of every machine. Let's understand the key technologies in a better way by looking into automation pyramid. In the automation pyramid, level 3 and level 4 defined as an information technology layer, IT layer. In this layer, most of the communications between modules and solutions are non-real time communication. Level 0 to 2 defined as an operation technology. In these layers, system and solution demands real-time communications. Let's map the new technologies, emerging new technologies to this manufacturing pyramid. Down on the shop floor, cutting edge technologies like edge computing enables faster, localized data processing, allowing real-time analysis without relying on cloud infrastructure. Mobile technologies and IoT connected equipment provides actionable data at the operator's fingerprints. Augmented reality, virtual reality transforms virtual AR VR transforms training and maintenance, offering immersive interactive learning experiences. Digital twin creates virtual model of physical system, enabling testing and optimization before making changes in the real world. Meanwhile, machine to machine communication enhances the machine interaction. Advanced robotics brings automation to the new heights, and 3D printing is revolutionizing prototyping and production with rapid prototypes, customized solutions, and RFID simplifies inventory and tracking reduction errors and increasing efficiency. At the top layer, at the enterprise resource planning layer, ERP and manufacturing execution system, technologies like cloud computing, big data analysis are revolutionizing how business handle vast amount of information, enabling real-time decision making. Cognitive computing powered by AML helps predict trends, optimizing processes, and make smarter decisions, while cybersecurity ensures that this valuable data remains protected. Blockchain, another emerging technology, adds transparency and security to the transactions, which is vital in today's interconnected manufacturing ecosystem. Whether you are working on AI algorithm, building IoT solution, or exploring robotics, the future of manufacturing is being shaped by innovation that directly related to your engineering field. Now let's explore the key programming language that used to build industrial manufacturing automation solution. Here you can see programming language at information technology level layer, operational technology level layers relevant to the respective engineering field. This doesn't limit but always possible to cross learning. At the top, level 3 and level 4, in the area of information layer, think ERP and MES has a brain coordinating the flow of information, resources, and processes throughout the manufacturing facility. Each language plays a unique role in making these systems effective, like Java, C Sharp.net, and Python are very versatile languages widely used in build reliable, scalable, and applications for both ERP and MES platform. As an engineer, understanding this language opens door to creating the backbone of enterprise softwares. Node.js, PHP brings server-side capabilities often used to build and manage web applications within ERP and MES, offering engineers powerful tools for real-time processing monitoring. Kotlin and Rust provides high performance solution. Kotlin offers a powers Android application in ERP system, while Rust is valued for its speed and security, ideal for handling complex tasks safely and efficiently. About SQL. SQL is go-to language for managing a databases. Since ERP and MES systems handle vast amount of data, SQL is critical for data storage, retrieval, and analysis. This is at the top level 3 and 4. When it look level 0 to 2, in the area of operation technology, these programming area brings manufacturing automation to life, from designing application to integrating hardware and creating a industry ready solution. For application level development, languages like Angular, .NET, Node-RED, Qt, Go, or Swift and SQL are essential. These are the programming for building user interfaces, handling data, and creating a smart application that support decision making across the pyramid. Hardware integration. Languages such as C++, Linux, Embedded C, VHDL bridge the gap between software and physical machinery, allowing you to control equipment, ensure precision, and enable real-time data collection on the factory floor. For design and simulation tools like MATLAB, LabVIEW, Unity, CATIA, and AutoCAD, SolidWorks are very invaluable. These allow engineers to model processes, simulate machinery, and visualize design before implementation that reduces the risk and improves the accuracy. Finally, industry standard like Codesys PLC programming logic controller are very critical for automation and controls in manufacturing. These languages are widely used for configuring programmable logic controller to manage processes, brings reliability and consistency to the complex operation in the manufacturing industry. Okay, once we had a look on programming language, in the world of industrial automation, being an engineer is not just about mastering programming language its alone. It's about building a deep, multifaceted knowledge that spans a range of competencies critical to Industry 4.0 and smart factories. Like, think of it like this: an engineer in today's manufacturing environment is not only responsible for writing a code, but must also understand entire ecosystem that powers a smart factory. This includes knowledge of framework that structure system databases that stores and manage massive amount of data, and communication protocols that enable seamless data flow between machine and devices. Beyond that, engineers need to be familiar with system architecture as well as a software configuration tools used to program and optimize the machinery. But it doesn't stop here. To truly thrive in the industry 4.0 world, engineer must also embrace modern practices like CI/CD, continuous integration, continuous deployment tool and method. These allow for efficient and reliable update to the systems, ensuring that production environments stay agile and responsive. Mastery of enterprise architecture helps the tie everything together, aligning technology with business goals to create a unified intelligent system for the manufacturing automation. One who aspires to build a career in industrial automation domain, it's important to recognize that future of industrial automation is not just about hardware or software in isolation, but about integrating everything: systems, data, communication, and technology together. This knowledge will be your key to success in a career that is driving the digital transformation of industry worldwide. Let's take a closer look at the key players and solution providers in the world of industrial automation. In this rapidly evolving field, different companies specializes in different layers of manufacturing automation pyramid. Some focuses on providing solutions at level 3 and level 4. These companies ensure smooth, intelligent coordination across the upper layer of the pyramid, allowing business to plan and execute production efficiently. Then there are companies who provide end-to-end solution, covering everything from level 0 to level 4, from physical machinery and sensor to all the way up to level 4 ERP and MES solution. These companies offers a comprehensive approach, ensuring seamless integration across all levels of the pyramid. As an engineering student, understanding the different roles these companies play in the industry 4.0 ecosystem will help you to appreciate the breadth of innovation happening across the manufacturing landscape. Okay, till now we come across, try to understand industries, smart factories, manufacturing pyramid, what all the technologies driving it, and how it is aligned in pyramid, what all the market key players, who are all the automation solution provider, and what all the programming language you need to focus. Here we can see highlighted the come some common challenges at work in the organization. Statistics shows rework, changes, unplanned work, unclear direction, inadequate technical knowledge, management and team related problems, and issues are driving organization towards inefficiency. To efficiently address these challenges, along with programming knowledge, organization also expects engineer to build a additional technical and soft skills. So, what are the essential technical and soft skills that can engineer must develop to build a successful long-term career in industry? System domain, system knowledge and domain knowledge, database management, software testing and debugging, version controls, DevOps, some of the technical knowledge additional to programming language, and some of the soft skills, time management, collaboration and teamwork, effective communication, and continuous learning helps to build a long-term successful career in industrial automation. Of course, needless to say, everybody practices work ethics and take responsibility for their action in the industry in their day-to-day work. Okay, here some of the statistics. Choosing a career path can be very exciting, especially in the field like industrial automation with endless growth potential. Here are the few insight to guide your decision, like most used programming languages worldwide and most programming language most demand in recruiters globally, and the technical skills developer acquired aspire to acquire the most demanded technical positions in the job market. You know, if you see here JavaScript, HTML, Python, and that's how the percentage wise across industry they were focusing on. Here, what I mean to say is consider these insight alongside your own interest and passion. Industry automation offers dynamic opportunities. Choose a path that aligns with what excites you and fits your long term career vision. Here we can see the training strategies in the industry worldwide. This statistics says around 69% on-job training, around 50% internship and cooperative projects, and 41% partnership educational institute, and so on. To all aspiring engineers, this is your chance to step into world of connected factories, advanced robotics, IoT, and AI-driven decision making. We can utilize various platforms and resources to gain valuable knowledge and hands-on experience in Industry 4.0 and smart factories. Here are some of the key approaches: online learning platform, internship, cooperative programs, hackathon, and university lab. There are university labs are set up at the colleges. You can explore it, you can leverage it to get a hands-on experience on industry use cases, virtual labs, and professional network with LinkedIn and online community. There are plenty of opportunities available. You can take it to your advantage for the learning. By immersing yourself in this platform, you will gain the practical skills and insights essential for navigating and leading in the next generation workforce. Okay, before taking up a question and closing, I would like to mention one thing. The future of manufacturing automation is exciting field, and you as a future engineer will play a key role in shaping it. Whether you are interested in designing the next generation of robots, developing AI solution or factories, or analyzing data to improve system, there are limitless opportunities are available and ahead. Start exploring now and you will be part of revolution that defines the next era of industrial automation. Yeah, I would like to stop here. If I am open for any question and answer.
Hey, thank you, Naveen. I think you have painted a wonderful picture. I think very good insight in the limited time that you had, and a very good overview of Industry 4.0. So let me
Thanks
start
so
off
much.
with the
Yep.
first question for you is while you showed, I think while I can see that Industry 4.0, like it's a wide spectrum of technologies. Uh,
Correct.
it encompasses different layers. As you gave a very standard, I think the industry has come up with a standardized definition as you've showed the 5 levels
Correct.
which are there. So do you have a recommendation in terms of if I am a student right now, where is so because I am not exposed to maybe any of these, or I am exposed to might be exposed to some of these, but
Mhm.
is there a focus which is possible, or in the end would you have to learn across the stack, you would need to know at least something?
So I trade that which level we need to focus, right?
Yeah, which level or which technology, I mean, what kind of combination would work? Or,
Yeah,
or
yeah.
is there a focus possible, or is it like we need to learn across the spectrum everything?
No, if you see, this is very industrial automation is very domain and engineering centric field. You know,
Mhm.
let us consider I am from a computer science information technology background. Okay,
Right.
I'm very much interested to learn Java, Node.RED, .NET
Mhm.
in the
Okay.
application top level. Yeah, let us consider my domain is artificial intelligence and machine learning. Okay, when I do data analysis, the data all belongs to shop floor. Yeah, the robotics, CNC machine, printing machine, any assembly line. For
Mhm.
anybody to analyze the data, it's very important to understand what the data mean. Yeah. So my point
Mm.
is, if any engineers, even though they work at level 3 and level 4, they must have knowledge how shop floor works so that they can take a better decision in their solution.
I understand. Mm.
Another important, let's consider, I mean, electronics and communication, electrical engineering. My focus will be more interesting, will be on the operation technology field. Let us
Mm.
consider I am implementing a real-time communication solution in my control system. Okay, when I expose to data, what kind of data structure is required at the top level, I should know, so that I can give upfront those kind of data format to the upstream. This kind of cross knowing, which accelerates the solutions.
Mm.
So example, okay, in the operation field, when I develop, I need to test from the user perspective. My solution will be used in the top layer so that I can, as a user trend centric testing, I can implement in my day-to-day activities. This is how it helps the across industry knowledge.
Mm. So any suggestions like how can students get any kind of exposure maybe during internship or through hackathons, I think, to how these things work, or can they do some projects?
Yes, yes. If you see, most of the industries already collaborated with the universities. Okay, that's
Mm.
how every industry leaders and in academia they're coming together, means how industry is facing up in the technologies, and there is a gap in hands-on experience with next generation students. Okay, that's how already there is a universities connected for the mtech interns or btech interns. That's the first. And also industries already in some colleges they set up a lab specifically on the industrial products, so students can play around, they can get a hands-on experience. That is from the directly learning from the organization. Okay,
Mm.
apart from this, it is a best way to registered in a online community like IEEE community and NASCOM community, or any LinkedIn community, where specifically the groups are formed to discuss about this industry. Okay, that gives a wide spectrum of knowledge. To get a individually also, we can, let's consider, we can buy Raspberry Pi, and there are so many embedded device already available in the market for very low price. Okay, take it, integrated it, it's a Linux system, connected to your PC, play around. I think it's a lot of platforms available to convert our knowledge into experience. But it's very much important for students getting into industry, they must have some bit of uh, at least I would say 1 or 2 levels of knowledge they must possess before joining the industry.
Shachi, do you have any questions for him?
Yeah, so yeah, we just discussed on some advices for the students, but I'm just thinking, what if I'm an engineer
Yeah,
who has worked so far with Industry 3.0 and I want to transition now
yeah.
to Industry 4.0? So would you give the same advice to me as would the same advice that you gave to the students would apply to me, or is there something different, something more that I'll have to do?
Yeah, if you see the transformation from industry 3.0 to 3.4, even though it's a revolutionizing, it is little easy to leverage for new setup factories. Let's consider you are building a smart factory. Everything's from scratch. It is easy to deploy this technology. But let us consider you are in industry 3.0 industry, where machines and equipments are little legacy. Okay, this evolved from last 3 decades, right? When you transform that into a new technology, there is a basic layer has to be digitalized. It starts from networking. Okay, because data has to be exposed, right? When to do that, data has to be exposed in every level. You need to make them IoT enabled. Yeah, every device has to be IoT enabled so that it exposes the data outside. Once it is data is exposed outside, in your 3.0 ecosystem, you have to make data center very strong, right? And once the data center is made it strong, means you have to ensure securities, because you are changing legacy system into new technology. Because in the industry 4.0 smart factory, you are starting with scratch, everything you can implement layer by layer. But transforming from industry 4.0 to industry 3.0 to industry 4.0, it's take much more investment and longer time, because legacy system has to be changed to the new system.
Mm.
And maybe some are no legacy coding and legacy IDE, legacy platform. It may not support AI ML. Okay, that slowly need to transform in every layer. This is what industry the current challenge is.
Correct. So I guess more of the projects that are coming, companies are doing would be around this transformation, right? Because most of the production in India, I would assume, would be at a earlier level. It has been set up maybe 20, 30 years ago. And only the new age factories which are getting set up maybe in the last 3, 4 years perhaps would be I4.0 enabled to some extent.
Yeah. Okay, this challenge comes very much in the developed country like US and Europe, right? Because they are engineering nation. They built their system from last 4 or 5 decades. Now they wanted to change into industry 4.0. There is a huge challenge. But if you see in the emerging countries, okay, they can take this advantage of leapfrogging. Okay, they no need to go every pain what developed country went. Okay, this
Mhm.
is I think bit different to
Okay.
differently face from developed country and emerging countries. If you see in India, okay, now in
Mhm.
the most of the SMEs are not leveraging industry 4.0. Maybe when later stage, when it's standardized, it's scaled, when the cost comes down, maybe SMEs can explore, but they no need to go the pain which developed country went. They can directly off the shelf, you can buy and implement in your new factories. But
Mhm.
if you want to transform a legacy factory, then it's a pain.
Mhm. So for new engineers, what kind of roles are available? Like if they join a company which is focused, let's say the manufacturing company in any of the
Yeah,
domains,
yeah.
what kind of roles are going to be available to them?
Actually it's also depend on which layer we focus. Okay, let us
Oh.
consider in the level 0, right? It's most kind of a production, assembly line and all. Okay,
Mhm.
there may be you can we can as a application programmer, yeah,
Mhm.
and maybe is a maintenance engineer,
Mhm.
or
Oh.
it may be like machine supervisory. Okay, this kind of in the manufacturing segment they can play around. Okay,
Mhm.
if everything is defined by software, and if engineering student would like to build their career in software field, okay, so different roles is on the like what I mentioned here, full stack developer, you know,
Mhm.
and
Okay,
back
okay.
end developer and front end developer. They focus only on UI UX. An
Mhm.
application developer and DevOps is very critical in anywhere in deployed to software. Okay, these are all the specific roles emerging also. Specifically now what we're talking about is cybersecurity engineer is also evolving much stronger. Okay, these are all the on the technology side. Okay, when you get experience, okay, and also role is also depend upon individual organization standard. Okay,
Correct, correct.
let's consider you getting into organization where they call it as a software developer. Okay, under software developer you can differentiate these. Okay, then
Mhm.
when they get experience they call it as a senior engineer, then they move on to architect, design expert, system expert. Depending upon the horizon, they'll expand in the pyramid.
Mhm. So would you suggest that basically I think people should also try to get some kind of domain expertise? Maybe, for example, Bosch is an automotive. When you focus on automotive and understand automotive, your knowledge of Industry 4.0 technologies would become much more relevant, and you will, as an engineer, you will become much more valuable for that particular industry, and you can build a career which is very focused.
Yeah, if you see the ABB, Siemens, Bosch, Honeywell, Beckhoff, these are all the similar no market segment these market
Correct.
players are playing.
Mhm.
Yeah,
Mhm.
when you see they have multiple business vertical. If you see the Bosch is not just the automotive. Okay, Bosch
Mhm.
is also a business for industry vertical, right?
Uh,
Okay, people can choose. Okay, if you is a Bosch, if you from bigger perspective, if you look, they have business in the energy, they have business in the consumer goods, they have a business in the
right.
automotive, they have
Correct.
business in the industrial automation. Okay, they can choose, but what we are showing is very exclusive to the industrial vertical.
Industrial vertical.
Yeah.
Got it. Got it. Cool. Shachi, do you have anything? I think I don't have anything more right now. We have also
Talk
kind of
about how it is easy for developing countries to just jump into this, right? So I want to know, in India, are there any organization that have implemented these the technologies of Industry 4.0 with a significant operational impact?
Yeah, if you see in the Bosch also plant in Ahmedabad and Bangalore plant. Yeah, I think this is the one example I can say. And if you see any manufacturing like HMI, I mean say Honda Motors, or Maruti Suzuki, or Volkswagen. Okay, not directly from that in the Daimler plant. Anything you take it right, two-wheeler or four-wheeler manufacturing industry, most of them they're leveraging Industry 4.0 potential, because they operate in a such a massive scale. Okay, these help them to optimize supply chain, optimize the inventory management, and optimize the procurement, and optimize the material flow. I think these the larger scale industry can leverage the best potential of this uh, solution. But if you see in the SMEs, of course, they may some bits and pieces in the operation technology they can leverage in India, specifically in India. But as a whole, I think it takes little more time to leverage the Indian ecosystem. But of course, if you see in developed country in Germany, and of course this the Industry 4.0 is coined in Germany, right? And in US. But here also we need to look the what is the driving. The labor is also a driving factor for leveraging Industry 4.0. Okay, when there is a shortage of skilled forces, okay, as in the developed country, they will accelerate this implementation in their industry vertical. But emerging
correct.
countries like Vietnam, India, and Latin America and Mexico, these countries little slow down in the implementation. But
Mm.
is they were leveraging it, but not as accelerate as the developed country.
Naveen, I think that was an excellent overview. I think we have uh, we'll stick to our time. I think there are more questions definitely, but I think there'll be opportunities beyond this webinar where we'll have more one-on-one engagement, maybe through panel discussions and all, where definitely we'll love to have you. I think this is an
Definitely,
excellent
definitely.
overview. So students, I think you definitely got a great overview. I think in terms of the kind of technologies involved and the kind of companies which are working and the kind of roles you might look forward to. I think it's a great insight. I think thank you, Mr. Naveen. This has been a fantastic presentation. I'm sure
It's
this will be a
pleasure.
terrific value add.
It's pleasure here. Thank you.
Thank you.
Thank you.
Thank you, Chitrai. Thank you, Suchitra. Thank you all. Bye.